So we do completing the square, meaning that we are doing question 3 of tutorial sheet 4. So what we'll do is we first put up a general statement, ax squared plus bx plus c if this is f of x, and then we are told to complete the square. What do we do? So our first step, our step 1 is to factor out a and remain with this without attaching the constant. So step 1, factor out a and then step 2, you divide the coefficient of x by 2 squared and have it subtracted. And then, so we are saying step 2 of the quadratic, you divide the coefficient of x by 2 and add and subtract its square. Then step 3, you take x, get that sign there, and put b over 2a, have it squared, then subtract b squared over 2a squared. Meaning it's going to be 4 now because we have squared it, plus c. So what do you do in step 3? We put x plus b over 2a in the brackets squared and expand the subtracted square. And then expand now a times x plus b over 2a squared minus b squared over 4a plus c. So notice that it was a squared, but as we are multiplying by the a from outside, the a squared down just becomes a. It does not reach c because c is outside the brackets. Expand or multiply by a throughout. Okay. So when you reach here, you say you have completed the square. And it's got nice properties. Its properties, if A is greater than 0, we say f of x attains its minimum value at x plus b over 2a is equal to 0, which implies that x is equal to negative b over 2a, and the minimum value itself is negative b squared over 4a plus c, giving the minimum turning point, negative b over 2a, comma negative b squared over 4a plus c. The first one. The second one, if a is less than 0, we say f of x attains its maximum value at x plus b over 2a is equal to 0, implying that x is equal to negative b over 2a, and the maximum value is still negative b squared over 4a plus c, giving the maximum turning point negative b over 2a, comma negative b squared over 4a plus c. So what does this mean? We can only have one of the two from any quadratic equation or function. So we'll never obtain the maximum and minimum at the same time. The function will have either maximum or minimum if it is a quadratic. Is that okay? Okay. So that now you do the same, even if the equation was equated to 0 and they ask you to use the computing the square method, you still do the same, except in such a case, you are able to divide throughout the A. We're now on question 2, part 1, where it says solve the following quadratic equations use the method of computing the square to solve each of the following. 1, 4x squared. Okay, I've gone somewhere else. 1, x squared minus 10x plus 24 is equal to 0. So to use computing the square method, the first step is to factor out a if it is not equal to 1. But now a here is equal to 1. So we move to step 2, where we were dividing the coefficient of x by 2 and square it, have it subtracted, add back the 24 is equal to 0, and then get x minus 5. Remember we said you always use this sign. So minus 5, have it squared, and then minus 25. That one which remains is that you square, and then add the 24 is equal to 0. And then we have x minus 5 squared minus 1 is equal to 0. To solve for x, we'll have this squared is equal to 1. Get the square root, get the square root. So x minus 5 is equal to plus or minus 1. So that x is equal to 5 plus 1, or x is equal to 5 minus 1, giving us x is 6, or x is 4. So this is what gives us the x values. Now in the normal quadratic function, we call such equation as, we call these values of x that are obtained as the x-intercept. So it won't be nice solving the whole of question 2, trying to just get the x values. The question that would be nice for us is question 7, which is building on this very concept, which says, for each of the following functions, find the maximum or minimum value of f, then sketch the function of f. So now what we'll do is we'll restrict ourselves to only completing the square and be able to sketch, because in doing so, we'll be solving also for such equations in looking for the x-intercept. So this means that we'll move to question 7, part 1, where we're looking for a sketch. So sketch f of x is equal to x squared plus 6x plus 5. So we complete the square. So again, we're starting there from step 2, where we'll have this plus 3 squared minus 3 squared plus 5, giving us x squared, and giving us x plus positive 3 square minus 9 plus 5. So get x plus 3 square minus 4. Now what we said is that if a is positive, since a is equal to 1 here, greater than 0, what we have is a minimum point given by x plus 3 is equal to 0, giving us x is equal to -3. So the point will be -3, comma this part here, -4. So now we'll have 2 new things to be added. The one we call the y-intercept. We said the y-intercept is always obtained by substituting 0 for x in the whole function. So that we get the constant, simply say 0, 5. So 0, c will always be the y-intercept, when sketching in here. Then the trick part now will be looking for x-intercepts. When we are guided that we should use computing the square.
Sir.
Hello?
You've left me behind from this part, from the x plus 3 squared minus 4.
So the x plus 3 squared minus 4, we have negative 9 plus 5, giving us negative 4. When we reach here, we say that we have fully completed the square. We're now trying to use the completed square to sketch this function. Okay. But remember what we said here on the properties. We said if a is greater than 0, we say f of x attains its minimum value at x plus b over 2a is equal to 0. And look at where x plus b over 2a is. It is in the brackets, is it?
Yeah.
So we'll go back and get what is in the brackets, equate it to 0, and solve for x.
Okay.
So we'll get negative 3 there. What else have we said? And the minimum value is negative b squared over 4a plus c. This thing here, which is standing alone away from the brackets. Meaning that in our case, we are talking of negative 4.
So in this case, there's nothing like us square rooting both parts, the x plus 3 and the negative 4.
So in getting these properties yet, we have not looked for the x-intercepts. We only do that when we look for the x-intercept. So far, we're just talking about this piece here and this piece regarding to the value of a.
Okay, sir.
Yes. So then, because we want to sketch, we also need to know the y-intercept, which is obtained by substituting x is equal to 0 in the original function. Then instead of going back to the original function to look for the x-intercept, after computing the square, you get this thing here, equated to equated to 0. So you have x plus 3 squared is equal to 4. This is the point now when you square root both sides. So you have x plus 3 is equal to plus or minus 2, so that x is equal to negative 3 plus 2, or x is equal to negative 3 minus 2, giving us negative 1, giving us negative 5. How do we use them in the sketch? So negative 1 and negative 5, that's where the graph will cut the x-axis. And then negative 3, comma negative 4, that's where the graph will have its minimum point. That's where the shape will look like that. And where it's cutting the y, we said it's 0,5. Remember that our points will always be x, y. So 0,5 means x0, y5. That is how we appreciate the computing of the square method. This is where it leads us. This is a very serious exam question with a lot of marks, because computing the square itself carries its own marks. Graphing also carries its own marks. How many points are there? We have 1, 2, 3, 4 critical points. So each point will carry a mark. Okay. So we get to move. Let's look at part 2, part 3. Okay, let's go to part 4 first. I want a different one. This is negative 2x squared plus 11x minus 15. Complete the square first. Take away negative 2. You remain with x squared. Then it will become minus because you are dividing 11 by negative 2. X, close, and have negative 15 there. From there, negative 2, and then x squared minus 11 over 2x plus, get 11 over 2 divided by 2. The easiest way of doing this is getting 11 over 2 and multiplying it by half. Hello?
Sir, this 15, negative 15 is not part of the factorizing. It's not, then get factorized.
We leave it alone because even if you factorize, when you multiply back by negative 2, it will be as if you have not done anything to negative 15.
Oh, okay.
So the easiest way of dividing by 2 to any fraction is just multiplying it by half, so that we get 11 over 4 and bring it here as a square. Quickly subtract the same square, subtract the 15. Then keep negative 2 still, get the x in the brackets, get the minus there, and get 11 over 4. Squared minus 11 squared is 121. 4 squared is 16 minus 15. And then expand, so we have negative 2x minus 11 over 4 squared plus 121 over. So how we multiply the negative 2 outside? We are saying negative 2 multiplied by negative 121 over 16. So when multiplying, we pay attention to the denominator here because we know that this 2 goes in 16 8 times. So we just write it as 121 over 8. Then minus 15. This is now a time when you get to add the 15 to the constant. So 121 over 8 minus 15 over 1. There is 8 down. You get 121 minus 15 times 8 is 40 here, carry 4, which is 120. So we get minus 120, giving us negative 2x minus 11 over 4 squared, that is plus 1 over 8. So now we can have this space so that we can use it for other things. Just when you reach here, if you want, your next step can be getting this whole. Hello?
I am behind. Where did the 121 go? I didn't see what you did there.
So the 121, where has it gone? It's here. So you get the 121 as a positive as it is, then subtract 15 over 1. Because we have this whole thing here, a constant outside, is it? So we put these numbers together.
Okay.
All right. Okay. So,
Sir,
you know,
why doesn't this -2 disappear after we divide it by the 16?
no, on that part it has disappeared, except that there was nothing to divide it with here. Remember, it's -2 multiplied by this part minus -2 multiplied by this part. So there are two things inside the brackets there. It's like you're having -2 multiplied by a plus b. You say -2a minus 2b, is it? Now the a is what we have in the brackets, and the b is a -121/16.
Oh.
Yes. Okay. So when you reach here now, we say, since our a, the coefficient of x squared is -2, which is less than 0, then we'll have the maximum turning point. Where at x minus 11/4 is equal to 0, which is x is equal to 11/4. So get 11/4, comma 1/8. The number standing alone there. And then f of 0 is -15. So the y-intercept is 0, -15. And then the x-intercepts, that's where now you get the whole equation, -2x minus 11/4 squared plus 1/8 and equate it to 0. So that you get -2x minus 11/4 squared is equal to -1/8. Divide the -2, divide the -2. So what we'll have now is x minus 11/4 squared being equal to +1/16. Since this is the same as dividing -2/1, when you reciprocate, it will become -1/8 multiplied by -1/2. Hello?
From this part, -2 x minus 1/4, where is this 4 coming from? This equation.
Which one?
This equation, -2 open bracket x minus 1/4 close squared plus 1/8 is equal to 0.
This is x minus 11/4.
Oh.
The one we have here. So everything that we equate to 0, yes. So now here, you get the square root. You get the square root. So we'll have x minus 11/4 is equal to plus or minus 1/4, implying that x is equal to 11/4 plus 1/4. This is giving us 12/4, which is equal to 3, or x is equal to 11/4 minus 1/4, which is 10/4 reduced to 5/2 if you divide by 2. Now we can sketch because we have everything that we need. So the intercepts are 3, 5/2. 5/2 also. These are the x-intercepts. Then the y-intercept is -15. Okay, let's go with turning point. The turning point is 11/4, 1/8. So your graph goes down, comes down here, where this is -15. So this is how we obtain this is how you make use of the computing the square method.